So you just want to get the volume that is represented by, well, before I do that, you got the sphere, and you just want the volume of the cap of height h. And they kind of, I think, no, they don't. A little bit, not really. I was wondering if they gave you a hint. So what do you want to... So you have some free range on this. This is the other kind of problem. It's not really made by rotating something. You have to figure out what image do I want to rotate, or think about this. Which axis do I want to use based on how they've set this up? So I could kind of turn the sphere around. I don't have to keep it the way they've given it to me. So remember, the way they did a sphere in general was they took cuts at certain x values, and they said, okay, here's my disk at that x value, and then you just add it all the way up, right? So they did it from whatever the radius, if it's a 1 radius, from -1 to 1. So that's not going to work here, is it, necessarily? It's you only want a piece of this. So I'm trying to figure out how to say this without just saying the answer. I kind of gave it away a little bit earlier with the first way that came to mind for me is I don't like the way they've given it to me.
You're trying to find h, right?
No, you're just trying to find the volume. So you're going to get some expression dealing with h somehow.
Or like similarly, like
Let me do this much. What's from here to there?
That's the radius.
So what's from...
yes, R to H.
Yes, R to H. That's it.
Yeah, but what's from here to there?
It's R minus H.
I love it. So you want some kind of integral from...
I don't know. We did function, right? Or do you want from R to R minus H? R to H R?
Yeah, you want to go from R minus H
To R.
to R. Be careful. So then you'll end up going across something that's H long. Does that make sense?
Makes sense.
Okay.
Yes.
That's as far as I'm going to take it. Hopefully, maybe that gets you guys going.
I thought-
Because if you don't like dealing with y-axis, you can just do it this way, or just color in the cap over here.
Because I was thinking of having as the point as the inner and outer. That's what I was thinking of, the R minus H. But I guess it's not.
No. The inner and outer have to be functions of whatever axis you're using as d what, right? So that would be the next level of this, is to figure out what function you're really dealing with. So before I rotate, to unrotate this thing, just to cut out a piece of it, here's what I'm really dealing with here, right? And if you can figure out, figure out the formula for this, or even better, a more direct way to do this is what's the area of, yeah, that's a little bit much. What's the area of each of these disks as they move up here?
Function sum, or the radius, which would be...
What's the area of that disk going to be? And remember, let's see how to tell this. So you're going along the y-axis, right?
Something circumference.
The way that we've got it set up. And we're going from the value r minus h to r on the y-axis. Is that cool?
Yeah, but it wouldn't be the circumference, would it?
Say again?
It would be the circumference, or it wouldn't be the circumference?
No. It's that wouldn't be a function. That would be a value. So I need a function that describes that. Or you think about, as you move up here, what's the area of these disks? And then you want to add them up along there. So if you look back at how they did the sphere, the general sphere, it's one of the first things they did. Here we go. On page 431. You actually can do exactly the same thing. You just have to be careful about how you define things. You can do the exact same thing, except you just use different limits. Right? You don't use the limits all the way from one side to the other like they did. So that's what I'm saying. If you turn your sphere so it's got the cap here, it actually really aligns well with that example. And you just have to change the limits that you use. You don't want to go across the whole sphere. You just want to go from here to
So
the
it's
top.
basically plugging those limits into the formula and then making an answer from there.
Yes,
That's simple enough.
not too bad.
So if we were to do it, if we were to rotate it that way, your distance would be h. What is it?
Yeah. It would be H here also. We're just not used to dealing with the y-axis where things are happening, right? It's just better for us to turn it this way. That's what we're more used to.
You're not given a function.
No, you're just given a shape.
You're just shape.
Yes.
So would you do the volume of the sphere? Would you use the volume function of the sphere? Or the volume?
No, you're sort of trying to figure that out in a way, at least a portion of the sphere. You can't directly use the volume of the sphere. You're kind of going this without knowing that. You have to find this volume directly using calculus, not using the portion of the sphere that represents. That's another way to do it. Just do a fractional piece of a complete sphere.
But you can't do it that way.
No, you can kind of check your work that way.
Okay. Might as well.
So that was number 49?
Yep.
In 6.2. Yep. Thank you. Is there anything else? Any other questions? All right. Let me see if I can remember anything else that you guys had trouble with. When I ask you to find where things cross, doing it in the graphic calculator or just telling me without telling me where they came from is not an option. You should be able to set them equal to each other, subtract, factor, all that kind of stuff. Should be second nature to us. There was some trouble with number 4 with figuring out how the off-axis rotation worked. So on number 4, I think everybody either went around y equals -2 or y equals -3. So let me just kind of do something in general here. If I've got a shape, everybody's shape should look something like that. And I'm going around, let's say y equals -1. And let's say this is f of x and this is g of x. So exactly, so right here, this is f of x, here's x. What does that f of x value really represent?
Bottom function.
True. But it also, if I was rotating this around the x-axis itself, what would that f of x represent? So you answered my first question. This would be the inner radius, right? But that's not the inner radius because I'm not going around the x-axis. I'm going around here. So how much further do you have to go? One more. Yeah. So it's pretty much going to be on this side minus -1. Or just think about it, I've got to go an extra 1 away. So my radius, both of my radii are going to be 1 longer than they would have been.
What if the bottom function was below the x-axis?
I love it. So then, if it's below, so if I have the same kind of idea, and I'm going around y equals -1.
The x squared plus plus squared equals 1. It goes around all the axes.
Should be 1 minus.
So same thing.
Yeah, so so now you think about it, the radius goes from here, the inner radius goes like that, right? So this distance here is how much?
So how would you find that then?
You know what it is.
One
So let me make sure you guys remember. So this is this bottom function is f of x, and this top function is g of x. So what is this distance here? f of x. I love it. That's what a function output tells me. It really tells me the height or the distance away from the x-axis, right? In this case, it's negative. You with me?
And in some parts, it's negative. Other parts, it's positive. As of that picture is.
So, since the rotation axis is on the same side of the x-axis as the function itself, you with me? So in this one, they were on opposite sides. So you ended up
Oh,
adding
you
them.
add the vector.
So on this one, how far would this really be? So how do I want to say this? So this is
1 minus
1 away. So this wants to be 1 away.
1 minus the function, right?
Function
Minus 1 minus f of x.
minus the function plus 1.
Sorry. All right. So let me see if I can come up with a different way to explain this. Let me do this. Let's see. So if I had this, I had to rotate that around the x-axis, right? Let me see if I can make this clear. Let's say this is at the point 1/2, negative 1/2. Now this is at the point positive 1/2. So I just kind of shifted everything up by 1. You with me? A little bit?
Yes.
So this would be f of x plus 1, right? That's what I've shifted it up by 1. Is it cool? So it's the old f of x, but I shifted it up by 1. So how far is this now? F of x plus 1. So the really funny thing is, how far is this?
It's just f of x because
How far is it away from this? F of x is this distance, right? And actually that's negative f of x if you really want to get down to it. So this would be 1, the whole thing, minus this much, which is negative f of x. Let's see what's f of x now.
so it's not
Negative f of x plus 1.
No, it should be that way. I might mess it up here.
minus 1.
Oh! I want to see this.
Well, that effect's going to be negative because it has, it's on the negative part of the y values, right? And we're just adding to it minus 1.
Oh, I'm being real stupid. So it's, alright, so if you want to look at it all, this is the exact same situation as this. Okay? And the one thing I'm kind of leaving out here is this is negative 1. So it's a full negative 1, right? Except, it wants to be a full negative 1, but it's got to take this much off. So it's negative 1 minus f of x, which is really, truly the same thing because it's going to be squared. It's really the same thing as f of x plus 1. So, let me see. I'm going to get a better example for that. So, it's really clear if I do this. It's really clear to see if it's all happening above this thing. And this is f of x, and this is g of x. And I put my rotation axis to say is at y equals 1. Now, how far is this going to be?
Left minus 1? Oh.
So how far is this?
F of x minus 1.
This is f of x, right?
Yes.
Okay. And so of course it's going to be minus that, which is 1. So it'll be f of x minus 1. Right? Okay. So it's easier to see when it's on that side. If I put it on this side, then it would be plus 1, because you're adding it in. Now, the minute I have something dipping below that axis like that, this is where things get weird, because, let's see if I can, maybe we made a specific, let's make a specific function here. That'd be better. Let's say f of x is Let's just say x squared minus 1. That'll make it easy. So that's my function there. It doesn't really matter what the purple one's going to be. This is x squared minus 1. And my purple one comes in and it does its thing. And then let's say I'm going around y equals negative 2. So I got to go around that. Now I got to figure out how far this is. Now at 0, how far away is that? How long is that arrow truly, the one I just drew in?
Yes.
Yeah, because this is really how long is this? This is 1. Right? How far is negative 2 away from the value of this at 0? So you can look